Today we will be reviewing polynomials. So recall, a polynomial is an algebraic expression formed by adding and subtracting terms. And terms can either be variable expressions or a constant expression. So an example of a polynomial would be something like 2x cubed plus 4x squared minus 7. So it's made up of a bunch of terms, added and subtracted. There are coefficients and variables or constant terms, and all the exponents on the variables have to be whole numbers and positive. So if there's one term, then that polynomial is actually called a monomial. And examples of that would be -6, xyz cubed, anything that only has one term, multiplication between everything, and no addition or subtraction. If it has two terms, it's called a binomial. So something like that would be 2x minus 1, or x plus 7z. Okay? Anything where it has two terms is going to be a binomial. 3 terms is a trinomial. An example of that would be x squared minus 7x plus 3, or x plus y plus z. If it has 4 or more terms, we don't have a special name for it. We would just call it a polynomial. And that would be something like x to the 5 minus 3x squared plus x minus 12. Okay, that's a polynomial. Collecting like terms, so in an algebraic expressions, terms are to be considered like if they share the same variable raised to the same exponents. So pause the video and simplify these examples. For the first one here, we have two different x terms. We also have two different xy terms. The order of the variables doesn't matter. And then we have one single y term. So we're going to put the xy terms first because they are degree 2, since the exponents on the variables would add up to 2. We have -5xy plus 4xy, so that would be -xy. Okay, and then the x terms would go next, because alphabetically they are next, and they're degree 1. So 7 plus 2 would be 9x minus 3y. Okay, same idea for the next one. We have 2x squared terms. And those are the highest degree, so they're going to go first. We'd have 2x squared. And then we have two different x terms. When we add those together, we get -5x. For example C, there are brackets. If there's nothing out front of the brackets don't actually do anything, and we can ignore them. And same thing if it's just a positive. If you're adding, the brackets don't actually do anything. Okay, but if it is a negative, then you have to think about it as a -1, and you're really distributing in that -1. So what we really have here is 2x plus y minus 8z plus 5y plus x plus 3z, and then minus 4x minus 10y plus 7z. So it just changes the sign of those last 3 terms. And then you want to collect like terms. So looking at all the x terms, we would have -5x. And then next, looking at all the y terms, 6 minus 10 would be -4y. And then last but not least, looking at all the z terms, we would have 2z. And that is fully simplified because there's nothing else we can combine. Next, we have to remember about multiplying polynomials. Okay, so if it's a monomial times a polynomial, then you're just using that distributive property, and you're just multiplying the monomial times each term inside the bracket. So 5x times 2x would be 10x squared, and 5x times 3 would be 15x. Okay, same idea here. We're just multiplying that monomial to each of the three terms. So 3y times 2y squared is 6y cubed. 3y times 3x is 9xy. And 3y times 2 would be 6y. If it's a binomial times a binomial, then you're going to FOIL. So first term times first term, that would be 12xy. And then the two outside terms, so 4x times 5, that would be 20x. The two inside terms, negative 2 times 3y would be negative 6y. And then last term by last term would be negative 2 times 5, which is negative 10. Okay, and then you would check and see if anything can be combined. In this case, they're not like terms, so you would leave it there. Next, if you have a binomial squared. So there's two different approaches to this. The first one is you can write it out twice, because that's what a squared really is. And then you can use FOIL. So 4x times 4x would be 16x squared. 3 times 4x is negative 12x. 4x times negative 3 is negative 12x. And negative 3 times negative 3 is 9. Okay, and then those two middle terms are like terms, so we would combine them. And there we have our expanded expression. Okay. The shortcut method is used when we have a binomial squared, and it will get you your answer in one step. So for the shortcut, what we do is we take the first term and we square it. So I'll actually write out the step. We're going to take that first term and square it, so 4x all squared. Okay. And then next we take first term times last term. So 4x times negative 3. And we double it. So multiply by 2. Okay. And then last but not least, we square the last term. So you can do this in one step because you don't need to write out this middle step. But squaring the first term would be 16x squared. First times last times 2 would be negative 24x. And squaring the last term would be 9. And that gets us to our answer in one step. So this is much quicker, and I do recommend that you guys use the shortcut method whenever you see a bracket squared. So here are some additional examples. So if you want, you can pause the video and then give these a try. Okay, for the first one here, you have to follow BEDMAS. So inside the brackets, you're going to simplify first. And within there, you're going to do multiplication before you do any of the addition or subtraction. So we're going to multiply in that 5. So we have 4x minus 1 plus 5x plus 10. Okay, and then simplifying within those brackets, we have a 9x and we have a 9. And then last but not least, we can multiply in that 3 to get 27x plus 27. And it wants it fully expanded and simplified, so that is it fully expanded. You don't want to refactor out that 27 because it is asking for it to be expanded. Okay, for our next one here, the first thing I would start by doing is I would expand this squared term using that shortcut method, and I'm going to expand this binomial because we're going to deal with that multiplication first. So the 5x is going to stay on the outside, and expanding this bracket, we square the first term. First times last times 2. and square the last term. So negative 1 squared is 1. Okay, and then once again the 3 is going to stay on the outside, and we're going to FOIL this out. So we would get x squared plus 2x plus x plus 2. Okay, we still have multiplication in both these terms, so we can now use that distributive property to multiply in the 5x, and the distributive property here to multiply in the negative 3. So 5x times x squared is 5x cubed. 5x times negative 2x is negative 10x squared. 5x times 1 is 5x. Okay, and then negative 3 times x squared is negative 3x squared. These we can combine to be just a 3x. So negative 3 times 3x is negative 9x. And negative 3 times 2 is negative 6. And then we can collect like terms here. And there we have everything fully simplified and fully expanded. Okay, so here's our next one. This time we have a trinomial times a binomial. But it's the exact same process. All you're going to do is you're going to take every term from our trinomial and multiply it by each term from the binomial. So 2x squared times 3x would be 6x cubed. 2x squared times 7 would be 14x squared. Okay, and same thing with the second term. You're going to multiply it by everything in the binomial. So negative 5x times 3x is negative 15x squared. Negative 5 times 7 is negative 35x. And then multiplying that 1 by everything would get us plus 3x plus 7. And collecting our like terms here, we would get negative x squared, negative 32x plus 7. Okay. So whenever you're multiplying polynomials together, all you're going to do is take the first bracket and multiply everything in the first bracket by everything in the second bracket. Okay. So here are some extra examples that you guys can pause the video and try, and then when you unpause, you'll get the answers. So for the first one, I just wrote it out twice, and then once again just took everything in that first bracket and multiplied it by everything in the second bracket, and then collected like terms. Okay. For part B, since you're multiplying 3 brackets together, what you have to do is choose 2 to start with. So I chose the first 2 and I expanded those, leaving that last bracket just tagging along. And then I took everything in the first bracket and multiplied it by everything in the second bracket and collected like terms.